Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to the Daily Check-In for July 2nd, 2020. It's the second day of July, and it's Thursday, which means Thursdays on the Edge. And today I'm going to be talking about a company called Hivecell that I got a briefing from, and this is a pretty interesting briefing, and I think their product is very interesting in and of itself. So I just kind of wanted to talk about their product a little bit and the larger ramifications of a product like what they've designed, because I think it's actually really cool, and it sort of sets the stage for potential competitors. Kind of, here's the bar, and you probably got to clear it if you want to compete with these guys. So that's what I'm going to talk about today. This is not being live streamed because I am on vacation right now when you're listening to this, or probably. So I wanted to record this ahead of time so that, I didn't have to try to do the live stream from the beach, because that could be noisy and I don't want seagulls to attack me while I'm live streaming. So with that out of the way, no housekeeping items for today. Just like and share the channel if you're enjoying the content. And before we get into the main topic, how are you? Let's check in. How are things going? I know it's Thursday for you. It's Wednesday for me, and I'm pretty excited to be on vacation. Hopefully you've got some kind of vacation or break coming up. It's a weird time. Not everybody's able to go out and do a vacation, but maybe you can do like a staycation. Maybe that's an option for you. I don't know. I don't know what your situation is, but hopefully you're doing okay and you're making it through this kind of weird and wacky time. So let's talk about this company called Hivecell. What do they make? All right, if I had to distill this down, they basically make these adorable little compute units. And when I say compute unit, it's, basically a mini server. It's got chips in it that do computing. In most cases, they're ARM chipsets. So it's an ARM chipset. It's got a battery backup. It's got integrated NICs. And that sounds pretty pedestrian, you're right? Like, okay, well, so it's Raspberry Pi. Well, it's much more powerful than a Raspberry Pi. More memory, more CPU power than a Raspberry Pi. It's also stackable. And this is where things get really interesting. Because they're stackable, literally meaning you can take one and stack another one on top of it and they snap together. That snapping together distributes power and networking across the two nodes that you've stacked together. And then you can stack a third on, and now you have networking and power across three nodes. And all you really need to do is plug a power supply into one of them, and it will distribute power across all of them. If you remove the power, it has a battery backup to gracefully shut down. Now, what is this thing for? Why would you want to purchase such an item? Well, it's really for edge deployments where you're not going to have a technical person there. You're not going to have someone who understands how to rack and cable a server, how to configure a switch. You literally want to ship them a few of these units. They snap them together. They plug in one network cable and they plug in one power cable, and they're off to the races. If something goes wrong with one of those units, you literally unsnap it from the stack, snap it back together, and you're good to go. You just ship them a new one and they ship you back the old one. That's pretty cool. But there's more. But wait, there's more. This is available as a managed service. So you kind of rent these things, right? So the support for the hardware is bundled in with an annual fee for each node you're running. So that comes with the software and support and the hardware support. So if something goes wrong with one of them, they'll ship you a replacement one to wherever this thing is running. And then the person who's there unstacks the one that's gone bad, stacks in a new one, and drops the bad one back in a box that ships back to Hivecell. That's it. None of this cumbersome, crazy replacement. You don't have to roll a tech out there. If someone is able to stack blocks, they can literally work with this. So it's dead simple. Okay, that's pretty cool. And it's a subscription-based service, so it's all consumption-based. The more nodes you have, the more you pay. Okay, that's pretty cool. And then the other thing that they're doing is they're also providing the software and applications that run on top of this thing. So the ARM version of this runs a Kubernetes cluster. The ARM version can run a Kubernetes cluster, or they have some other Linux variations that you can run, but the most popular one they have is basically a Kubernetes cluster. So it runs a Kubernetes cluster across these nodes. And all you need to do is deploy typical Kubernetes workloads to these nodes. And they have sort of a marketplace of things, a marketplace of options that exist out there that you could take advantage of. But that's the general idea. So there's a lot going on here. It's not just the hardware, it's also the software, it's also a managed service. It's also dead easy to install and maintain. You're not disassembling servers, you're not cracking them open. What are the downsides? Well, I mean, there's absolutely downsides to this, right? With simplicity comes less configurability. So they have, like 3 different versions of the Hivecell. That's it. If those don't meet your requirements, well, you're going to go somewhere else to find something that does. Okay, that's fine. The other thing is that you can't repair it on site. So if it was a simple thing that could be repaired by a regular tech, you're still shipping it back and shipping a new one. And it's also linearly scalable. So if you want to add more compute, you're adding another node, which also has a certain amount of storage with it, which is normally fine. But if you think about it in the inverse, you're usually bound by CPU and not storage. So you run into the problem if you need more storage, you're necessarily adding more CPU, whether you need it or not. That was one of the problems with hyperconverged infrastructure. It didn't scale. You couldn't scale the components individually. I think it's less of a problem in this case because the cost of the unit is not that high. And if you really need that much more storage, you could potentially send some sort of NFS NAS type device to be the backend storage for whatever you're setting up. Yeah, that kind of blows this model out of the water a little bit, but you could do that. It is an option. Something that they told me during the briefing, which is now an official announcement, and it's part of the reason I waited to do this video, is I wanted to wait till this was official. They're coming out with a new version of the Hivecell. So they had Hivecell like V1 and V2, I think, but now they're coming out with one that's called Hivecell Z. And the big difference with this one, the confetti canyon with this is it runs an Intel processor instead of an ARM processor, which means it doesn't have to run Linux and Kubernetes workloads the way they were doing. It can also run VMware. It can run regular ESX on there. And they've worked with VMware to get vSphere 7 running on these little nodes. Okay, now why does that matter, right? So vSphere 7, for in case you didn't know, supports not only virtual machines, but also has a Kubernetes control plane and can support container workloads. So if you are a virtual machine type shop today using VMware, you could throw these units out there and push VMs to them and just run the VMs that you're typically running today. No big deal. But if at some point down in the future, you switch over to containers, you can now use your existing VMware management plane, VMware control plane, to control these clusters that are running out on the edge and deploy containers to them or virtual machines. You can go either way with it. So I'm thinking about all this and I'm like, wow, there's a lot of potential here. Now, it doesn't go into a rack. It doesn't go into a traditional data center. This is not the play here. It's not for somewhere that's going to have a tech person on site. This is literally for locations that have no technical staff. The units themselves are fairly ruggedized, so they can be in less than optimal environments. They don't need to be in a tightly cooled and controlled environment. You can put them out in the open and stack them. I mean, probably not outside, but you could put them in an environment that is not cooled in the same way that a traditional data center would be, and they'll just work. And they're not these tiny compute devices that can't do anything. They can actually compute and do real work. So I thought it was a very interesting approach. And according to the founders and the people that I talked to at the company, they're having trouble keeping up with demand. They build this hardware in-house. They design and build the hardware in-house. So this is not them just slapping a label on something from Supermicro. They're actually building this stuff from component parts and shipping it. And I thought that was really interesting because You're getting this unique design that's designed by them, and it's also managed by them and supported by them, everything from the hardware all the way up to the software. That's a really compelling value to me. Now, I don't want this to be a complete commercial for Hivecell. I just thought their solution was really interesting. And if I were a company, a hardware company that's looking to break into the edge, I would use this as a model to break in. So the Dells of the world, the HPEs of the world, I wouldn't be surprised if they start taking notice of this and start redesigning some of their stuff to do what this company does, or potentially just come and buy this company. I'm not sure how interested they are in being acquired, but that could be an option as well. So I thought it was just interesting to tell you about this model. Check it out if you want. I'll include a link in the description. But really just thinking about, here's a way to develop and deploy a simplified and cloud model type service, but out to the edge. And for me, that's really interesting. So that is, those are my thoughts for Thursday on the Edge for this week. Tomorrow, I'll publish a video that is about HashiCorp Vault. So if you're interested in the Vault certification, tune in then. And until next time, stay healthy and stay safe, everybody. Thanks.